Hello students. Now we are going to start a new chapter, that is chemical thermodynamics. It is very important chapter related to some basic concept of thermodynamics and some calculation of different types of energy related to this chapter. Thermodynamics is a branch of chemistry which deals with study of different types of energy and its interconversion and its quantitative measurement. How the different types of energy is related to heat energy, how heat energy is converted to other types of energy, how heat energy is converted to work done. So like this, how different types of energy is interconvertible, we will discuss in this branch of chemistry, that is thermodynamics. Thermo means heat, dynamics means change, how this heat energy is converted to other types of energy and vice versa. Before this starting of this chapter, let us discuss some important terminology, different terms, some basic concept used in thermodynamics we will discuss. This chapter is very much important because we have already read in chemical kinetics related to that the speed of reaction, the rate of reaction. Some reactions are very fast, some reactions are very slow, some reactions are moderate. So only it explains the mechanism of reaction, the slow and fast nature of reaction. But whether the reaction is possible or not, whether the reaction is feasible or not, thermodynamically or kinetically, some reaction kinetically is possible but thermodynamically is not possible. We have also this thing is observed. So thermodynamics, we have to know some important basic concept regarding thermodynamics. So today we will discuss only some basic concept. So the basic concept in thermodynamics mainly start from, that is, what is system? What is system? What do you mean by system? System means the part of the universe under study. Part of the universe under study. Under study. Part of the universe under study. Whole things, everything is the part of the universe. So the specific part of the universe under study, that is called system. For example, water in a beaker. Here water is a system. You can say it is the system. Water taken in a beaker, let us study the water. What is the temperature of water, what is the volume of water, what is the shape of water, like this. How much heat contained by the water, how much heat is absorbed by water, like this. But the water is called system. Water is here is called system because it is a part of the universe. What is meant by surrounding? Surrounding means that the part of the universe other than system. Part of the universe other than system. That means remaining part of the universe other than system. When you exclude the system from the universe, the remaining part is called surrounding. That means, suppose water in a beaker, outside beaker part, that is called surrounding. Outside beaker. Example is here, outside of the beaker containing water. Okay, so that is called surrounding. And both system and surrounding, if what, both system and surrounding gives universe. That is total. System and surrounding together gives whole universe. System may be a small one, system may be a large one, but it is a part of the universe. We are also a part of the universe. Suppose when you discuss about a particular student regarding the height, weight, like this, so that student will be considered the system under study. The part of the universe under study is called system. Everything will be considered as a part of the universe. That's a system. System plus surrounding results universe. Then third thing is, here is very important, boundary. What is boundary? Boundary is the wall to separate system and surrounding. The wall. This wall may be a conductor, may not be a conductor. Conductor sense, it may conduct heat or may not conduct heat. It may be a conducting wall or non-conducting wall. So the boundary is the wall which separate the system and surrounding. That means which brings the change in between the system and surrounding. The change of the system and surrounding is done through the wall. That wall is called the boundary. So beaker, your example is beaker. Beaker, whole beaker, that is called the what? Boundary. So system, surrounding and boundary, these are the very important concepts, important terms in thermodynamics. Another important thing is, that is, what do you mean by types of system? Types of system. Types of system are in the part of the universe under study. It depends upon what type of property, what type of physical quantity you are discussing for the particular system. When the system is expressed in terms of particular physical quantity, that is, taking one particular physical quantity remains constant, but changing the other quantity, that in this way, system may be divided into different types. First one is, that is, open system. Already I have told you what physical quantity of this system undergoing change. On that basis, system are different types. System is maybe an open system. Open system means here it is clear that exchange of heat and or energy. You can take heat or energy, exchange of heat and mass. Both exchange takes place. For example, we take this one. Suppose this is the water in a beaker, open beaker, water in a beaker. Suppose you are heating the water. If it is heated, then water will be evaporated. Here what happens? Both mass of the system, mass of the particles of the system, and both energy. It is absorbing heat. So exchange of energy, here energy or heat is absorbed by the system. So that water is converted to vapors. That is evaporation. Here vaporization takes place. The water converts to vapors due to vaporization and acts by taking heat from the surrounding. From the surrounding, the system absorbing heat, taking heat and convert to vapors. That is in gaseous state. So here both system can exchange. The heat can exchange and the mass also can exchange between system and surrounding. That's why it is an open system. Then closed system. What do you mean by closed system? Closed here says that only energy exchange, only energy exchange, but energy exchange, but not energy, not mass. Here energy will be exchanged, but not mass. For example, heating the substance in a closed container. Here what happens? We are supplying energy. The water in the container will absorb energy, but as it is closed, the water vapor cannot go outside. Suppose when you are heating the water in a pressure cooker, if the whistle of the pressure cooker, let the whistle of the pressure cooker is fixed, it cannot move. We know when the whistle of the pressure cooker will be opened, then the gas will come out. The vapor will come out from the pressure cooker. If it is tightly fixed, if you heat the water, sometimes not very strong heat, just little bit heat you supply to water in a pressure cooker, then by fixing the whistle, then what happens? The vapor of water remains in the pressure cooker, it cannot go outside. It cannot go outside. This is a closed system where heat can exchange, but matter cannot exchange. Mass cannot exchange, but heat can exchange. That is called closed system. Then isolated system. Isolated system here indicates both mass and energy do not exchange Both mass and energy do not exchange. Mass will not be exchanged, energy will not be exchanged. That means no heat can be absorbed or no heat can be evolved. In this sense, suppose water in a thermoflask. Water in a thermoflask. Water in a thermoflask. Here what happens, as it is isolated, and the wall of the thermoflask is isolated, it is closed also, that's why heat and your mass cannot be exchanged between the system from the thermoflask to outside. There will be no exchange of heat and mass. No matter, no energy can be exchanged. That's why here it is called isolated. Thermoflask, we can use the thermoflask for keeping tea hot, or you can use the thermoflask for storing the samples so that it cannot be contact with external factors, it will not contact with the surrounding heat. That's why it is isolated. No mass, no energy will be exchanged, that is called isolated system. So on the basis of mass and energy exchange, there are three types of system: open system, closed system and isolated system. Then another part we will discuss what is the meaning of that state of a system, or state variables. State of a system, or that is called state variables. What is the meaning of that? We know system means it has some mass, it has some energy, or it possesses some, it can be expressed with different parameters: temperature, pressure, volume, number of moles, like this. So, state of a system is the condition of a system to express its properties. What are the measurable properties possessed by the system? What are the measurable properties? What are the measurable physical quantity possessed by the system? So, we can say it is the condition of a system to express, to define the physics, to define the properties of the system. The condition of a system, system to express its properties. This condition is called state of a system, and that is also, and these properties can be varied from when the system undergoing change. When the system undergoing any change, then it is show change in the state of system, and you show the change in the property, that is called state variables. When the property changes, these are called state variables. To express the system, we have to define, we have to use some specific properties like what? Temperature, pressure, volume, etc. So these are the state variables, or these are the state of a system to express the condition of a system with specific properties. Temperature. What is the temperature of system? What is the temperature of water? What is the volume of water? How much pressure given by gas? So at the particular condition, that's why condition should be fixed. Before heating water, what is the temperature of water? After heating, what is the temperature of water? So these are the state of a system or state variables. We can say state variables because when the system undergoing change, then the property of the system changes. That's why these are called state system or state variables. Then another important property, that is called state function. State function state function. Already we have discussed that system has some measurable, particular system, its properties can be measured, and if the physical quantity of the system, when it is measured, if this physical quantity is changes during the change of the system, and it only depends upon initial and final values, but does not depend upon the progress of reaction or the path of change, that is called state function. State function means the properties which depends upon the initial and final value. It depends upon initial and final value, but does not depend on the path of progress. It does not depend upon the path of progress. That's why it is called state function, or it is also called what? Path function. It is also called as path function. Or state function. That means only depends upon initial value and final value. For example, potential energy is a state function, because suppose you are standing on the roof. If suppose you are going to top of the terrace, you are going to the top of the roof. Suppose you are going means you can go using your escalator, or you can directly go on the top using ladder. So by different way you can reach at the top. But at the top the potential energy and at the bottom potential energy are not same. At the bottom potential energy is high. At the top is potential energy is low. Anyway, that's why your movement so change in the potential energy. But initial value and final value will be changed. So during state function, the properties, the thermodynamic properties should change. Particular properties should be changed during the change of the system. But how the system change, what are the path of progress, how the system change from one condition to another condition, what is the progress of change, that does not depend. So potential energy is a state function. It is a state function. But work is not a state function. It is not a state, because to bring some change in the work, so system will do work. That means only it depends upon the path of progress. For example, you can do the graph that suppose P versus V. How much work is done? How much work? Suppose this is starting from A and to B. how much A to B can be done by this way. So A to B directly, or it can go in this way. If you change the path, the amount of work done, that is PV, will be vary. P and V value for different path will be different. Product of pressure and volume will differ because this is the graph area. The area covered by the system during the change will differ. It will have different work done because the area will be differ from this to this. From A to this through the cut path, the area cover is not same through direct path. That's why work is done. Work is not a state function. It depends on if the physical quantity depends upon path. That means by different direction, different value you will get. That is not a state function. But if any direction, if you are changing the direction, but the initial value and final value will be changed, but what way you are bringing the change, it does not depend. That is called a state function. Potential energy is a state function. Work is a state function. Okay? So this is called state function. This is called another state variables. So these properties which express the particular system, and these properties are called macroscopic properties. Macroscopic properties. Why it is called macroscopic property? Because the study of atom is meaningless. Study of atom is meaningless. When we are considering any system, any matter, then it has some large amount of atoms, large number of molecules. That's why we are discussing the properties of system in a bulk, not in single, not in individual. That's why the property is called as a macroscopic property. Temperature of water, that is microscopic properties. Pressure of the water is a macroscopic properties. Heat contained by the water, that is a macroscopic property. That means it does not indicate the individual atoms or molecules. It indicates as a whole, the whole system. That's why it is called macroscopic property. Each property generally called macroscopic property because it is expressed as a whole. So macroscopic property generally two types. One is extensive. Second one is intensive. Extensive property and intensive. Extensive property means it mainly depends upon the mass. If mass is more, the property is more. Only depends upon mass. Depends on mass. But it does not depend upon mass. That's why what is the extensive property? That extensive property you can say that volume is extensive property. Then heat is extensive property. What is volume, heat? Then so many. And generally we are discussing volume, heat. That we will discuss later. That enthalpy, we will discuss later what is enthalpy. That is heat content. So these are called what? Extensive property, because this property changes with mass. If you take small mass, volume will be small. If you take a large mass, volume will be large. If you take small iron, hot iron, the heat possessed by a small piece of iron will be less. If you take a large piece of iron, hot iron, the heat content will be more. That's why it depends upon what? Mass. If the property depends upon mass, this is called extensive property. If it does not depend on mass, that is called intensive property. For example, temperature is intensive property and pressure is intensive property, because temperature, Suppose you take 1 glass of water, temperature is same as 1 bucket of water. Because if you are taken from the same source, if you take from the same source, then the small amount of water, the temperature is same as the large amount of water. That's why it is intensity property. And pressure is intensity property. Pressure is that is force per unit area. It is fixed. Amount of force per unit area, that is fixed. That's why pressure is intensity property, does not depend upon the mass. Temperature, pressure, and density. Density also, that is surface tension, you have read, surface tension, like this. So these are called intensive property. Only it does not depend upon the what? It does not depend upon the mass. But extensive property, it depends upon the mass. So on the basis of that relation with mass, there are two types of property: extensive property and intensive property. Okay? You write down this one, then we will see. Then the types of process. What do you mean by process? Process means when system undergoing change in its properties, then we can say the system undergoing a process. Process means when system shows a change in its properties, that is called process. Process means system undergoing change in its properties. System undergoing change, then we can say it is called process. When the system shows change in its properties, that is called a process. There are different types of process. Isothermal process. Isothermal here means the property will be changed, the system property will be changed, keeping temperature constant. This process occurs but at constant temperature. When temperature is constant, for a particular change, if temperature, suppose you bring change in the volume and pressure. If pressure is changed, then volume will be changed. Just according to, we can say isothermal, that is Boyle's law. If you apply Boyle's law to the gas, that is, you can say it is isothermal process. Isobaric. Isobaric process means here pressure is constant. Pressure is constant. That is isobaric. We can say example Charles law. For a particular gas, you apply Charles law. That is called isobaric process. Pressure is constant. Change in volume, change in the volume and temperature of the gas. Isochoric. Isochoric process means here volume is constant. Volume is constant. That is Gay-Lussac law. Gay-Lussac law. Gay-Lussac law. Relation between P and T at constant volume. Okay? Gay-Lussac law, here the relation between pressure and temperature at constant volume. That is called isochoric process. adiabatic process. Here adiabatic means what happens? Here heat is constant. Here heat will be constant. You can change any physical quantity. You can change, you can bring the change the physical properties of system. Keeping heat is constant. There will be no heat is absorbed or no heat will be evolved. That is called adiabatic process. So on the basis of this, but if you draw a graph, it will be like this. If you draw, suppose this is the process. Here suppose this is your pressure, this is your volume. So we can say this is this process. This is the pressure is constant. This is your isobaric process, and this is your here volume is constant. This is your isochoric. This one is isochoric. This is your isobaric, and here this one and both this one. This is one called adiabatic, and this is called isothermal. These are just graphically how can you distinguish isochoric, isobaric, and your adiabatic, and that is isothermal. This is a very important distinction between these three types of process when system undergo change in properties, keeping one property constant. That is called different types of, you can say different types of process is possible. Process means change of the system. When system undergoing change, we can say the process is observed. That for that condition, for this change, we have to bring one particular property keeping constant. So on that basis, process may be reversible. When the process is called reversible process means the system after undergoing change return to the original state. A changes to B, then B changes to A. That's why it is called reversible. That means it returns to the original state. The state, that means the state of system will be achieved again. A changes to B, then in this case the property of system changes, but again return to A. But condition is slowly. That means during the change, the infinitesimally small change of the property occurs. The property A to B changes very slowly. And if it will be occur very fastly, then it cannot attain when it returns back, it cannot attain the same change between the initial to final. In this case, if it occurs slowly, then the individual change at the particular moment for the particular instant can be achieved. That's why slowly, when the change occurs slowly, that is called slowly, and the system returns to its original state. It attains the same physical properties or thermodynamic properties after bringing the change. That's why it is called what? a reversible process, and during reversible process, the system return back with the same way that it already changed to the B. When the system after the change to the particular condition again return to the original state, but during the change, during the path that it attained same physical properties, same thermodynamic properties during each infinitesimal small change during the process. So that is called reversible process. Then what is irreversible process? Irreversible process means if the system is not showing the reversible character, that means A changes to B, but this change is very very fast process. A changes to B very fastly. If it changes very fastly, then when it return back, it cannot attain the same change before it changed to A to B. That means during the returns, if it is changing to again return to the initial stage, but there will be not attending the same change during the path of process. During the process backward movement, there will be no change in the similar change in the path. That's why it is called irreversible. Almost all natural process is irreversible. No doubt it attained the initial stage and final stage. It returned to the initial stage and final stage, but during the path of progress, it will not attain the same change that earlier. That's why it is irreversible. That means if the process is very fast, that is irreversible process. If the process is very slow, it may be reversible. It does not mean that all slow process is reversible. No, but if it is returning again back with the same change, doing the same change and slowly, that is reversible. If the change occurs very fastly, then it is irreversible. So this is the different types of process. So in the next class, we will discuss some important physical quantities used in thermodynamics. Okay? Thank you all.